Back to Further Solutions Academy. Further Solutions Academy. Encourage us more to share and subscribe if you have not subscribed before. Make sure you press on your subscribe button. Presently, we have over 250 videos on our platform. It means you can come here and learn any topic of your choice. Any topic of your choice. And if you are expecting any topic to be available and it's not yet available, you can leave a comment below or you contact us with this number 2348034495998. Now with this line, you can do three things with it. The first thing, you can call us, you can also WhatsApp us, and Telegram is allowed. Telegram is allowed. You can do three things with it. And call, WhatsApp, and also Telegram. Now, what I have for you on this video is known as efficiency of a cell. Efficiency of a cell. Now, the outline of this video, the first one I'll be talking about efficiency itself. The second one I'll be problems on efficiency and solution to problems. Solution to problems, which is known as questions and answer, anyhow you call it. By the end of this video, I think something good will be up. Okay, now let me start from the first outline, which is known as efficiency of a cell. Efficiency of a cell. When we talk about efficiency of a cell, it always involves power output and power input. Please take note of that, which I've mentioned that in one of our previous videos. Okay, power output, when I was explaining work energy and power and the lights. Now, power output with the rate of power inputs multiplied by what? 100. Very important. It means efficiency of a cell. Let me denote it by E of F. It will be equals to power output divided by power input multiplied by what? 100. Multiplied by 100. Now, back to as a mathematics, I've been telling you that mathematics and physics are very close. They are good friends of each other, especially change of subject or formula in mathematics is very, very needful in physics. Now, it means I can denote it or interpret this statement to make a symbol. I can say that E of F equals to, now I will call it let me call it R naught. Okay, let me call it P naught divided by P1 multiplied by 100. I'm not doing something new. It means power output is P naught, power input is what? Just to make it very, very important, I think. Now, when we talk about power output, my power output, which is my P naught, is always equals to what? V squared of R. V squared of R, which is, we all know that. Now, and power input, which is P1, it will be equals to square of what? Big R and this. That is to say, efficiency, it will be equals to square of R divided by what? Of R plus small r. Now, where this we cancel this, it means I can say that it will be equals to R divided by plus what? Small r. And I've told you earlier that my R, my big R is external resistance, while my small r is internal resistance. Please take note of that. Very, very important. Now, what can I do? Or another way, or I can say that what E equals to potential difference. The potential difference across external resistor divided by potential difference across internal no across sorry I've made mistake here. Potential difference across external resistors divided by electromotive force of the cell, which I've explained that earlier, that my E is equals to electromotive force equals to R plus what? Which of I? I've done that earlier in our previous video. Anyway, I'm going to now with this, let me try to generate one or two problems question that will illustrate this point, which is now on our outline 2. On our outline 2. Okay. Now let me have this question. A cell, a cell of internal resistance, which is we all know as small r, supply. How do I spell supply? Okay, supplies current to a 6.0 ohms resistor, and its efficiency is 75%. Find the value of R, which is my small r. Now, this is the problem I have at hand, and I've told you all about what I know about efficiency. I'll break it down. Now, if you follow what I've said earlier on efficiency, this problem should be very, very simple for you to tackle, to solve. Now, let me quickly interpret all what I'm given, which is my parameters. Now efficiency, it will be equals to what? 75%. Very correct. My big R, which is external resistor, is 6.0 ohms. Now, what else did I have? Okay, that is very, very good. What else did I have? Supplied, and that is all. Now it means I can say that what? My efficiency, with what I've said earlier, it will be equals to big R divided by what? Small plus small r multiplied by 100. Multiplied by what? 100. We all know what is my efficiency is 75 equals to what is my R? 6 divided by 6 plus small r multiplied by 100. If I want to do it very well, as a math student, I can divide all through by what? By 100. It means I'll be having 75 divided by what? 100 equals to 6 plus r. Now, which I'll be having 0.75 equals to 6 all over 6 plus r. Now, can you see that it's moving to where I will get my answer, which I will cross multiply. We know what is called multiply in mathematics, which is 0.75 bracket over 6 plus r equals to 6. If I should open brackets, I will have something very good, which I'll be having by 4.5 plus 0.75 r equals to 6. If I should collect like times 0.75 r equals to 6 minus 4.5. If I should do my normal something, it will be here will be 1.5, 0.75 r. I should divide both sides by what? By r. My r will be 1.5 divided by 0.75. With this, I can now say that what? 15 and 75. Okay, which is it will be equals to it will be equals to 2 ohms. That is all. That is what? Oh, now with this, please make sure you go to your books, your literatures, and gather more problems on this part. I think this one example is more more very okay for everyone to understand. Now, Jesus. Let me bring out one problem that also help us. Will also help us. Alpha. Now, a resistor of resistance is, let me just cut it off, connected across a cell if the terminal potential difference of the cell is reduced to 1/4. Now, this is the technical part of which we need to understand of its electromotive force. Express the internal resistance R of what? The cell in terms of big R. Now, I've told you that we have big R, we have small R, and I've been on it since and over and over and over. Now, how do I solve this? It's a very nice problem and simple, but it's a bit logical. Now, how do I know? I will know that electromotive force, it always equals to V plus small v. I have to extend this area. Or I can say my electromotive force equals to what? Of big R plus what? Of small r. Now, please, you are must to think in the right way. If your thinking is not proper, you may miss it from the beginning. Now, because the question is telling me about internal and external resistance. Now, it means, and also, we are referring to what? Electromotive force. It means I must think this way so that I can see a connection on the what? On the problems. By so doing that, I can say that with my internal resistance now, I can say my internal resistance, which is it will be equals to electromotive force minus what? Minus divided by I. Please, what did I do there? I just mathematics, changing of subject of formula, which is there's nothing there. I subtract both sides by this, and I divide both sides by what is attached to what I'm looking for, which is I, current. Now, by so doing that, I can answer that what? Now, from the question, we're not, but from the question, terminal, which is potential difference, which is V, equals to what? 1/4 of what? Which, that is the problem. 1/4 of its electromotive force. 1/4 of the electromotive force. It means, therefore, I can say that what? My electromotive force equals to 4V. Electromotive force equals to 4V. Now, by so doing that, I can now substitute R, substitute this into this, which is, let me just, now I want to substitute now. It means my R, it will be equals to, we are of V minus what? Of IR divided by of my R. That is what. Now, don't forget, from Ohm's law, let us to know that this is applied. Okay. Now, by so doing that, I can now continue by having, okay, yes. Now, we all know that by V equals to that, which is my R, will now equals to 4IR minus IR divided by I divided by what? I. By so doing that, my R equals to 3IR divided by I. This is I. I will move out the story, which is 3R. That is my answer. That is mine. And can you see it's very, very simple, but it's a bit logical. You must know what you are doing. That is just it. That is just it. Now, let me show another problem. But that's okay. I think it's getting better. I want to see you in flying color in all your exams and real part of life application. Physics is more, you can apply it to anywhere. How I wish you can understand what I'm saying by in Skylab is now. I have this type of problem here, which is should be the last question, and I want to make it tedious. And electric bell takes a current take its current of 0.2 ampere from a battery of two dry cells connected in series. Okay. Each cell has an electromotive force of 1.5 volts, so I'll be able to handle, and an internal resistance of 1.0 ohms. Now, number one, calculate the effective resistance of this bell. Number two, what current would the bell takes if the current, the cells were arranged in parallel. Now, these are the two problems I have, and okay, let's see what we can do to this problem. Solution to this question. There are two questions. The first one is what? Calculate the effective resistance of the bell, and what current would the bell take if the cells were arranged in parallel. I think from the beginning I've explained series connection and parallel progression, both resistance, voltage, and cells. Please take note of that. Okay, now it's now time to apply it, and which I'll be very happy. I wish I can give this as an assignment, which you get back to me, and I'll be very happy. But let me try to do it. Now, I have this type of problem. I've told you earlier, your has or not, it's good to draw your circuit. Now, the first thing I will think of, I will try to draw my circuit of number one, because these are the instruction, and the resistance bell takes a current of 0.2 ampere from a battery of two dry cells connected in series. Each cell has an electromotive force of this, which is 1 this, and it means there are two cells, which is now time to draw my circuit. As I'm looking at it, these are two cells. This is cell 1, this is cell 2, which in series. Is series. Now, it means I'll be having E of 1 equals to what? 1.5 voltage, and internal of 1, which is small r, it will be equals to 1 ohms. And is also E of 2 equals to 1. And also, that is interpretation number 1. Connected in series, which is I've interpreted this of. Now, let me continue my drawing. Now, let me call this place a bell, which is my R. We all known as big R. Now, current is being flow, which is my current is 0.2 ampere. My current is 0.2 ampere. By so doing this, my problem is what? Half solved on number 1. My problem is what? Half solved on number 1. Total electromotive force, which is known as E, will be equals to E1 plus E2, which I've explained on our previous video. Now, by so doing that, it means I'll be having my E of 1.5 plus 1.5, which it will be equals to 3 volts. 3 volts. Now, I will also move on. Total internal resistance, which is my R, will be equals to R1 plus R2, which I'll be having. What is my R? It will be R1 plus 1, which is known as 2 ohms. 2 ohms. Now, since I have this, what else can I do? Now, what is my current? I need my current also. My current, which is my I, it will be equals to 0.2 ampere. 0.2 ampere. I can now continue by having, okay, what can I do? We all know that my current equals to electromotive force divided by R plus small r. Yes. It means 0.2 equals to, what is my which is going to be 3 divided by 2 plus, big R plus 2, which I'll be having. What else can I do there? I can cross multiply, do whatever I want to do, which is 0.2 bracket of big R plus 2 equals to 3. What else can I do? Now I can say 0.2R plus 2, that will be 0.4. 0.4 equals to 3. 0.2R equals to 3 minus 0.4. 0.2R equals to, it will be 0.2.6. My R, it will be equals to 2.6 divided by 0.2, which is my big R, will be equals to, it will be 13 ohms. 13 ohms. That is all. 13 ohms. It means my answer to number 1 is what? 13 ohm. Now, the story now change that, okay, don't forget that my big R, which is this, is now 13 ohms. My R is 13 ohms. Please take note of that. Now, to tackle the second problem, what current would the bell takes if the cell were arranged in parallel? Now, don't forget that our external resistance is already given, which is known as 13 ohms. Please permit me to rub this solution to number 1. Permit me to rub solution to number 1 because of the space. Please, we need your support. You can help us so that we can buy a larger board. We need no amount is small. I will give you my account number. There won't be problem. Just help us. No amount. It can be in dollar, it can be in pounds, anyhow. Okay. Now I want to solve the second problem. Because now what current will it take if the cell were arranged in parallel? Now I will draw my circuit. Very important. Mind you, my this is already given, which is 13, and I will continue by having. Now, this is the bell, which is now equals to 13 ohms. Now, to be continued, this is my current, which is flowing around. Now, in now, can you see this connection is already in because of cell. Cells were arranged in parallel. It's not in parallel. What are we trying to say there is that this is going to be what? We have E1, which is going to be what? 1.5 volts, and R1, which is going to be 1 ohms, and E2 1.1 volts, and R2 1 ohms. That is all. What is that? My bell is already given, which is the resistance is 13 ohms. We know what is my current is. My current of I. Now, what current will it take? It means this time around you cannot hold on to what? On 0.2 ampere, because the story have changed. This time around you are looking for the current that will flow, because the current visually, the current of series is not the same thing the current of what? Parallel. Take note of that information. I've told you earlier, and I wrote those things. Make sure you follow them up. Now, okay, series connection and parallel connection, that took it. Okay, now we are now back here. It means electromotive force, which is known as V as E, will be equals to it will be equal 1, 2. I've told you earlier, which is 1.5. It will have equal electromotive force. That is further. Now it means my resistance will be divided by what? R1 plus R2. I've told you earlier, which is please make sure you watch this video. I won't go back to that place. It means I'll be having 1 multiplied by 1 divided by 1 plus 1, which is equal to 1 over 2 ohms. Now, 1 over 2 ohms. My big R is already given, which is 13 ohms. Now, I can now continue by having my current, which is divided by I, will be equal to E bracket of R plus small r. E bracket of I plus small r. Now, everything you need is already available. What is my E? 1.5 divided by, what is my big R? 13 plus 1. Which I have this as 1.5 divided by what? 14. 1.5 divided by what? 14. Okay. No, sorry, it can't be 1. It should be 1, or sorry, 1 over 2, which is 0.5, which is, I will be having 13.5. Sorry for that mistake. Sorry, I made mistakes for that. Sorry. Now, since I have that, I can now press and have my calculator, which is good to know how to handle without calculator anymore. 13.5 and is it 1.5 divided by 13.5? It will be 0.11. 0.11 ampere. Make sure you put the units there so that you be able to interpret what you are doing. Okay, I think you can see how nice, how simple we are talking about. In our next video, I'll be working on electrical energy and power. Please don't make sure you view that video. It will be very interesting for you. Don't forget you are home with further solutions. Solutions Academy. Help us to share and also subscribe. If you have not, make sure you do that. Subscribe to this. Once again, thanks for watching.